Okay, let's look at exercise 2. So for exercise 2, it is actually the extension of exercise 1 because additional plane, okay, located at z equals to 4 will be added to the to this situation. Okay, the current density here is 10. Okay, 10 x in x directions, so we have to find a total magnetic field at the same location, which is 1 1 1 and also 0 -3 -10. So now we have additional plane located at z equals to 4. So this is the previous plane, okay, in exercise 1, and this is the new plane located at z equals to 4. So these are the points, okay. So at 1 1 1 we will calculate the magnetic field, okay, contributed by this new plane. So at these locations, okay, we will use the equations. So for the x negative z, you get positive y, so you get 5 unit vector y, so at these positions. And for this point, okay, use the same equation, okay. Just now for the unit vector n, it is pointing downward, okay. So from the plane we point towards the observation point, so it is heading in the negative z directions, okay. That's why negative z. As for this one, same thing, okay, pointing downward, okay, in the negative z directions. So I will get 5y, okay, for this point is magnetic field. So for the total, it will be the dimensions. Okay, so at point 1 1 1, it will be 5y plus 5 y direction, so equals to the 10, okay, amperes per meter in the y directions. As for this point, okay, the magnetic field will cancel each other, so the total magnetic field at this point will be 0. So now let's look at the third exercise. Okay, so now you have an infinite line, okay, located at y equals to 1 and z equals to 4. So it carries filamentary current, okay, with this value along the x directions. Okay, so while the z equals to 0 plane carry another current, okay, this is the current density along the x directions. You have to find the magnetic field at this point. So in this question, you have a line and also a plane, so you need to find a total magnetic field. So for this case, okay, so I list down, I have a line and also I have a plane. So we go to the line first. This is the line located at y equals to 1 and z equals to 4, and the current flow in the positive x directions. Okay, the magnitude of the current is this one. So if I redraw this current filament in the two-dimensional figure, okay, so this one will be the direction of my x pointing out from the page, okay, x, okay. So in the x direction, so this is the y equals to 1 and z equals to 4. Okay, so for the infinite line, using the Ampere's law, I have to use these equations. So we already tried many exercises how to use these equations. So first of all, we need to find the r. So before we find the r, we need to find the t. T is a point that is located along the current filaments. It has the same, okay, sorry, it creates a 90 degrees angle, okay, when we link it to the observation point. So this is the point T. So point T, it will have coordinate y 1 and coordinate z equals to 4. As for the coordinate x, it will follow the coordinate x of the observation point. So the point T is 3 1 4. So unit vector r will be the observation point minus the point T, so you will get this one, and this is the magnitude, and this is the unit vector r. Okay, as for the phi here, okay, it is the dl cross with the unit vector r here. So current flow in the positive x directions, okay, so I will get this one, and I replace it to the equations, and finally I will get this one as my answer. Okay, this is the magnetic field which is contributed by line. Next, we move on to the plane. Okay, the plane is very easy, located at the z position 0. Okay, this is the observation point. Okay, your observation point is 3 4 5. So basically it is located at height of 5, okay, above it, okay, 4 and 5, 4 and 5, okay. So use these equations, okay. The magnitude of the current density 20 milli in the x direction, cross product with this one, okay, is pointing upward, so it is z directions. So I will get this one, okay, negative 10 milliampere per meter in the y directions. Okay, so the total magnetic field at this point will be this one, okay. You just add the magnetic field here with the magnetic field here, okay. So you just add them together to get a total magnetic field.